we did had a rational function in it, and then we did one that had a quadratic, and this one has a radical function. And I think after that we've done them all. Because if you look at 18's rational, but we did one like that already. 19's rational, 17 is like this one. On the other page, I think they're mostly quadratic. So I just want to make sure that we cover one of each kind. So you're going to do the exact same thing. You're going to set the two equations equal to each other, because we're using substitution. So square root of 2x minus 5 equals negative 2x plus 7. Now what should I do?
Plus 5.
2x
Oh.
plus.
Thank you. Okay, so now what do I do to solve this? Good. We got to square both sides because I need to get rid of that radical. So I'm going to square the left in order to get rid of the radical, and that means I need to square the right. Yes. So on the left, that cancels the house top and gives me 2x plus 5. On the right, I'm going to actually just go ahead and write it down twice so that I don't FOIL it incorrectly. So I need to FOIL it out. And let's see, that gives me 2x plus 5 equals 4x squared minus 28x plus 49. Now when I get to this step, now I'm back to solving a quadratic. So I'm going to move everything to this time to the right-hand side in order to solve my quadratic. So I'm going to subtract 2x from both sides and subtract 5. So now I have 0 equals 4x squared minus 30x plus 44. Now, at this point, you could use the quadratic formula if you wanted to, but I think this factors, and I personally would rather factor, so I'm going to try and factor it. It has a GCF of 2, so I'm going to factor that out. That leaves me 2x squared minus 15, oops, there's no x on that, sorry, plus 22. Now I'm going to have to use bottoms up method because I still have even though I factored out a GCF, I still have a lead coefficient of 2. So I'm going to multiply first and last. That gives me 44. So my new trinomial would be x squared minus 15x plus 44. And that factors x minus 11, x minus 4. Don't forget the 2. We brought this 2 down. So I have to put it back underneath. This 2 just follows along too. It's in front. Okay, I'm going to simplify this. 11 halves doesn't simplify. So I can bottoms up that, and it would be 2x minus 11. The other one does simplify as x minus 2. And all of that was equal to 0. Everybody sort of okay? Just factoring? Okay, now once I get to this point, because they were all equal to 0, then I take each piece and set it equal to each factor. Factor 1, factor 2, factor 3, set them equal to 0. So 0 equals 2. Well, it doesn't. You don't have to worry about it. Anytime you factor out a GCF like that, doesn't matter that it doesn't equal 0. Then I have 2x minus 11 equals 0. So 2x equals 11. So x equals 5.5 or 5.5. And then x also equals this one, x equals 2. So I have 2 answers that I found. Now here's where you have to be careful. And I know it was a long time ago, but you have to think back to when we did radical problems. Radicals can create extraneous roots. That's the first time we learned that word. That means answers that you get when you solve the problem that aren't really answers. The only 2 functions that we've discussed in Algebra 2 that do that are radicals and logarithms. So anytime you do an equation that has a radical in it, you have to check your answer. So I'm going to go back and check both my answers, 5.5 and 2, against this original equation, the one that I wrote in black, the square root of 2x plus 5 equals minus 2x plus 7. I'm going to plug them both into that and see if they both work before I even try to find an ordered pair, because there's no sense in me finding an ordered pair if it's not really an answer. So I'm going to do the square root. I'm going to do the 5.5 first. So 2 times 5.5 plus 5 equals negative 2 times 5.5 plus 7. Okay, well that's 11 plus 5 is negative 11 plus 7. Square root of 16. The square root of 16 is 4. Now yes, when you take a square root, you can get both positive and negative 4, but remember when you're checking these, you check against the primary root only. So you check against, when I take the square root of 16, it gives me 4, and 4 does not equal negative 4. So even though I got 5.5, it's an extraneous root. And I don't have to find the ordered pair for that one. I'm going to check the 2 just to make sure it works, and that the answer's not no solution. So I got 2 times 2 plus 5 equals negative 2 times 2 plus 7. That's the square root of 9 equals 3. 3 does equal 3. So 2 is a real root. So now that I know that, I have to plug it back in and find my ordered pair, which I really just did, but we'll do it again. So I'm going to plug it into this one because that's easier. Y equals negative 2 times 2 plus 7. So it's 3. So my ordered pair is the ordered pair 2, 3. I know that seems like an awful lot of work, but again, you only have to check for extraneous roots. The only functions we've discussed that do extraneous roots are radicals and logarithms. And on this page, we don't have any logarithms. That doesn't mean you couldn't, but we don't have any on this page. So that's all you have to check for. Is everybody okay?
Yeah.
All right, now I want you to go back and start with number 13 and solve the rest of them.